How much protein is too much for a meal? Quickly and easy calculate your optimal daily intake with our protein intake calculator. When you consume food, it must pass through the stomach and into the intestines before it is absorbed into the body. Food ingested loses its form in the acid bath known as the stomach, and turns into an indistinguishable mass called chyme. Chyme is pushed through the intestines by peristalsis, and the outer layer gets eaten, or taken up, by the walls of the intestine into the body. Getting amino acids into the intestines. Dietary protein, or amino acids, that lay around in the gut will be absorbed into the intestines, and later into the body, by amino acid transporters. There are many different transporters that take up amino acids. The overall amount of absorption can be determined by measuring fecal amino acids. If not absorbed, nitrogen's only other significant route is rectal excretion. Can I eat too much at once? Amino acids and some peptides are able to self-regulate their time in the intestines. An example of this is the digestive hormone CCK, which, in addition regulating appetite and satiety in response to food, can also slow down intestinal contractions and speed in response to protein. CCK is released when dietary protein is present, and demonstrates a way in which the body can slow down digestion in order to absorb all present protein. Protein storage and release. Small intestines be saving my muscles? The small intestine is where, under standard conditions, 95% or so of dietary protein is absorbed, with the unabsorbed fragment going to the colon to be fermented by bacteria. The small intestines are also an organ, and they need nutrients to survive as well. The small intestines will absorb a lot of amino acids, but may eat some to survive and proliferate. Almost half of eaten amino acids are used by the gut and related tissues, with the gut consuming more of the amino acids found normally in animal products. Specifically glutamate, glutamine, branched-chain amino acids, threonine, cysteine, and arginine. Free amino acid pool? Due to the aforementioned ability of the small intestines to hold on to protein, they are considered a free amino acid pool that the body can draw amino acids from on an if-needed basis. It's not wholly in-out storage though, as the intestines may partake in some recycling and bring up amino acids to turn into glutamine, their main fuel source. During periods of protein deprivation, the gut may reduce its need to use amino acids as fuel though. Putting it all together. If we assume the final goal is health, you can consume a fair amount per sitting, as the gut will tend to slow down absorption and feast happily on the amino acids. The body will tend to slow down absorption in response to how much you eat, as the presence of amino acids can self-regulate their own digestion. In a study done on women, consumption of more than 54 grams of protein in a single meal versus across 4 meals resulted in no differences. As these women had on average 90 pounds of lean mass, it is highly plausible that more protein could be efficiently processed. 30 grams of protein? You may have heard that you can't digest more than 30 grams of protein in one sitting. When you eat protein, your body doesn't use it directly. Instead, it breaks it down into its constituent amino acids and uses those to make its own proteins. However, your body doesn't use dietary protein only to make muscle, or even only to make other proteins. Moreover, your small intestines are able to absorb and store a large amount of amino acids, ready to be used when your body needs them. In short, the idea that eating more than 30 grams of protein results in wasted protein is incorrect. Your body will break down and use all the protein you eat, sooner or later, one way or another.